So we've been working on dividing fractions, but there is a simpler way, which is simplifying. And if we do that ahead of time, we actually make our lives a lot easier. So let's check that out. So our very first step, just like before, we are checking, can I divide? My numerator is 12 divided by 9. It's not a perfect integer. It does not work out. I can do 16 divided by 8, but because I can't do 12 divided by 9, I cannot just divide. So again, we're going to use that multiplicative inverse. We're going to keep the first one exactly the same. And then instead of dividing, we're going to do the opposite is multiply. And then we're flipping 8/9 and using that reciprocal exact opposite. So now we're doing 12/16 times 8/9. So we have written it as a multiplication problem. Now, 16 times 9, I don't know that off the top of my head, but I do know factors of both of those numbers, and I can simplify by their GCF. So if I start listing factors of 12, which are 1 and 12, 2 and 6, 3 and 4, and factors of 16, 1 and, not 2, 1 and 16, 2 and 8, 3 cannot go into 16, but 4 and 4 can. So looking at 12 and 16, they don't have a common factor of 12 or 6, but they can both divide by 4. If I do 12 divided by 4, the answer is 3. And 16 divided by 4 is 4. So now I have 3/4. That's a lot simpler than 12/16. That's going to be easier to use those numbers. Now really quick, let's take a look at 8. They have 1 and 8, 2 and 4. And can I squeeze 9 over here? I think I can. 1 and 9, 3 and 3. So their GCF is 1, and dividing by 1 is going to keep them exactly the same. 8 divided by 1 is 8, and 9 divided by 1 is 9. So we're not going to simplify those ones because it's already simplified. So we have simplified by the GCF. We have 3/4 times 8/9 now. Now we're just going to use the commutative property, which is to flip our multiplication sideways and see if our numerators can simplify any more doing that. So we're going to keep our denominators the same. And we're going to switch the order of our numerators. So instead of 3 times 8, we're just going to flip it around and we're going to do 8 times 3. Now we're going to check these GCFs. So we already have factors of 8, but we need factors of 4. 1 and 4, 2 and 2. And their GCF is 4. These can both divide by 4. 8 divided by 4 is 2. And 4 divided by 4 is 1. We've simplified it even more. And now let's look at 3 and 9. We already have factors of 9. So factors of 3 are just 1 and 3. And I see they both have a factor of 3. That's their GCF. So we can divide these both by 3. 9 divided by 3 is 3. 3 divided by 3 is 1, right? We have all the answers right in our factor charts. Now we're as simple as we can go. We're at 2s and 1s and 3s. None of those can simplify even more. We have a way easier problem than 12 and 16 and 8 and 9. So now we can multiply our new numerators, which are 2 times 1 is 2, and 1 times 3 is 3. So this problem came out to 2/3, and it's already simplified. We don't need to go any farther. It's not an improper fraction. 2/3 is our answer. So simplifying ahead of time saves us a lot of work in the end. It makes my multiplication problems easier. It makes simplifying at the end easier. If I do have to divide at the end because I have an improper fraction, that's also going to be easier because I'll have smaller numbers. Simplifying first, I promise, saves a lot of time. Factors are easy to list. We can do it.